Namaskar. Myself Vivek Bajpayee is going to explain topic current electricity for class 10th. Conductors. Substances which conduct electric current through it are called conductors. To understand current electricity, it is necessary to know about the conductors. There are two types of charges. Two types of charges. Two types of charges therein. Any conductor. These are electrons and protons. Electrons are negative charge particle and protons are positively charged particles. Electrons revolves around nucleus in confined orbits and protons constitutes nucleus along with neutrons. Okay. So that electrons are mobile charges. I'm not going in deep to explain it why these are called mobile charges, but briefing is required to understand the whole topic. Electrons are mobile charges because these exist in orbits and electrons present in outermost orbit are called are called valence electron. By giving some amount external energy or force, these electrons leaves their orbit and start moving like free electrons. Starts moving like free electrons. Okay. So these are mobile charges. Mobile का मतलब which can move from one place to another place. Thus, an electron is denoted by E, and charge on it is minus 1.6 into 10 to the power minus 19 coulomb. It is charge on one electron, and coulomb is the unit of charge. So now we can give an definition to the charge. What is charge? Which is flowing in any conductor, which causes electric current, that can be defined as charge. The integral multiple of charge on one electron is called charge. It is given by Q is equals to NE. Q is equal to NE. This may be positive or negative, because the charge on proton is also equals to plus 1.6 into 10 to the power minus 19 coulomb. So that charge can be positive or negative. And in the definition of electric current, it will be said, so that here the definition of electric current. the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. That is denoted by I. Then I is equal to Q upon T, rate of flow of charge. So I is equals to Q upon T. Either you may use a small q or capital Q. That doesn't matters. Okay. The unit of SI unit. The SI unit of current is Q. Q, that is Coulomb. Upon second. So Coulomb per second, or so SI unit of I is Coulomb per second or ampere. In short form, ampere can be abbreviated as A. Now, next, electric current. Now potential, electric potential. What is electric potential? There we have said that the mobile charges electrons. So don't get confused while the electric potential is explained, and according to definition you will be given as electric potential, the work done to bring unit positive charge from infinite to any point of conductor is called electric potential. It is known as electric potential. It is denoted by capital V. Then V is equals to W upon Q. Q is unit positive charge. Unit positive charge, it is according to quantization, unit positive charge Q. Unit you may take 1, 2, 3, 4, 5 coulombs, etc. What the unit you have decided, what the reference you have decided, that must be unit positive charge. If you are going to take 1 coulomb of charge, then 1 coulomb of charge. 1 coulomb Q is equal to Ne. Q is equal to Ne. Then 1 coulomb is equals to N into 1.6 into 10 to the power minus 19. Then N is equal to 6.25 into 10 to the power 18. If 18 electrons or proton, if positive charge is being taken, then 6.25 into 10 to the power 18 protons. If it is taken negative charge, so that it will be 6.25 into 10 to the power 18 electrons. In both cases, you should understand this point. And now if it will become 1 coulomb, 2 coulomb, 3 coulomb, so that this multiple 1 at the place of 1, it will be 2, 3, 4, 5, etc. That will be your own unit charge. Okay. Now, so V is equal to W upon Q. V is equal to W upon Q here. So, W is SI unit of W. What is W is work. Then SI unit of V is equal to unit of W, means work, upon unit of charge. Unit of W. What is unit of W? That is joule. And charge coulomb. Then charge, so that here joule per coulomb, or it is volt. This is volt. So unit of V is volt. It can be abbreviated as V. Now, this is voltage, electric potential. Electric potential. Now, potential difference. Sorry, here one more thing should be defined. 1 volt, and here I have left 1 ampere current, so that first at all 1 volt. What is 1 volt? So here V is equal to W upon Q, that is 1 joule upon 1 coulomb. So 1 volt, it will be V is equal to 1 volt. So how it is defined? 1 volt, 1 volt of potential can be defined as to bring 1 coulomb of charge is brought from infinite to any point of conductor by doing 1 joule of work. So this is 1 volt. Different writers has defined it differently, but now at the same time, at this instant, what is better, what is written by me, that is the definition. You must understand. Don't get confused. All the points are clear here. So potential difference. What is potential difference right now? And 1 ampere will be explained in next page. Firstly, potential difference, because I have given the heading here, written the heading here. So potential difference. What is potential difference? Potential difference is nothing. This is also potential, because there it is infinity. In physics we always consider infinity, but actually we don't know the limit what is infinity. So that we have to be restricted. For this, potential difference is used. What is potential difference? There is no change in definition. The work done to bring unit positive charge from one point of conductor to any point of conductor is called potential difference between 2 points. Suppose here this is a conductor. This is a conductor, and this is a point A, and here this is the point B, and it is brought Q coulomb of charge by doing W work from A to B, then what will be the work done? Then V VAB. So it will be VAB. That will be the potential difference. Then it will be written VA minus VB. What will be? VA minus VB. Okay. So VA minus VB, that is W upon Q. The next formula is also W upon Q. For the class 10th, this is quite sufficient. Not necessary to explain it more. This is W, work done from A to B, then VAB, VA minus VB. Okay. So this is the potential difference, and its SI unit is also volt. Here I am writing volt. Next. So students, I think you should be understand. So 1 ampere should again defined. One ampere. So what is 1 ampere? 1 ampere can be defined as I is equals to 1 coulomb 1 second. That is 1 coulomb per second. That is 1 ampere. So when लाइट ऑन कर दो. When thank you. When it passes one coulomb of charge from any point conductor in 1 second then it is said the current at that point is 1 ampere. This is 1 ampere. You can define it such a way. Okay, dear students, potential and definition of 1 ampere. Further, I am going to discuss about Ohm's law. What is Ohm's law? Ohm's law. Ohm's law. At certain physical conditions, temperature, the potential, difference is directly proportional to the current flowing to the current flowing. Then V is directly proportional to I. Then V is equal to I R. Here R is proportionality constant. R is proportionality constant. R is proportionality constant. It is also known as resistance. It is also known as resistance. So R is equal to V upon I. The SI unit of R is ohm or ohm. To learn this ohm, the girl of 2 choti. Okay. The SI unit of R is ohm. Now, R is equal to V upon I. You can also draw a characteristic graph between V and I. For Ohm's law, or for ohmic conductors, the VI graph will be a straight line. VI graph will be a straight line. How? Here this is V in volt and I in ampere. So the graph will be a straight line, and the slope of graph is equal to resistance R, that is V upon I. This up to here. So this is V, and here this is I. So V upon I is equal to R. This is R is equal to V upon I. Now, resistance. Resistance, it plays a very important role in current electricity, because without knowing resistance, you can't do any problem regarding to this chapter. Here, resistance. What is resistance? Resistance. This is a property of a conductor, resistance. Actually, the material of conductor is made up of tiny particles, and these tiny particles are compressed or weakened to each other. Vicinity means nearest one. This is not wicked. This is vicinity. Vicinity means contracted or stick with each other, very close contact. Actually, that is the vicinity. So resistance, I'm going to define resistance. What is resistance? The obstruction offered by the material of conductor. The obstruction offered by the material of conductor in the flow of current is called resistance. Is called resistance. So resistance and what is obstruction? Obstruction means opposition. Suppose you have gone in any fair and the whole mass is coming out of from a small gate. Many people are rubbing to you. Then your ears will become reddish. Your ears will become hot. That is resistance. Why that is resistance? Because you have worked a lot to come out, and people has opposed you to go out. Okay, so this is resistance. Here similarly, here electron is passing from one point to another point to carry the current. These electrons strikes with one to another. Means the particles of material strikes with electrons, and their kinetic energy get converted into potential energy, and that kinetic energy is also converted into heat energy, so that the wire get heated. While the current is passing through any conductor, any wire, then wire get heated, na? So what is that? This is the current. This is the resistance. Due to resistance, the wires get heated. Okay, so resistance depends on certain property of conductor. Resistance is directly proportional to the length of conductor. So R is directly proportional to L.